All right, in this, let's work out this multi-loop circuit. So what I have here is a circuit, which I'm just going to first show you how to do this without any numbers. So here I have this circuit. There are no numbers, but I've labeled some directions for the currents, and we're going to use those. But I want you to know, and I'll show you an example next, where I don't give you the direction for the currents. But here, I've already labeled them. Right? So I'd take I1 to be in that direction, I2 would be in that direction, and I3. Now, from this circuit, I have several unknowns. I have I1 is an unknown, I2 is an unknown, and I3 is an unknown. So I have three unknowns, and so in order to solve for those three unknowns, I'll need to have three independent equations, three equations that are independent of one another. I can write actually four equations from this because I can use the junction rule at one junction, and I can write the loop rule for three separate loops. Now you might say, well, it looks like there's two loops in this, but there are actually three loops. Let me show you. There's a loop here, there is a loop here, and then there's a big loop here. All right, so I have three separate loops that I can use. So first of all, let's use the left loop, and I'm just going to pick a direction. I'm going to start up here. I'm going to go in this direction. Doesn't really matter what direction you choose. If I were to choose the other direction, it would just be like the negative of the equation that I'm going to come up with. As I come to each element, I'm going to ask myself, is this a positive or negative change in potential? Well, in this case, it's going to be positive V1. You see my electrons come in with a little energy, and they go up that little ramp, and they gain energy. And then I go through R1. That's going to have a negative change in potential, which is going to equal negative I1 times R1. Being very careful to keep my subscripts correctly. I'm doing a left loop here, so I'm going to come up here. Here, my V2 is going to be negative because I'm going from the high side to the low side, and I have this little slide which goes down. So my electron is actually losing energy in that battery. It's like a recharging. Now this next one, be careful here. It's going to be plus I2R2. And then this is equal to 0. Being careful in this last element for a couple of reasons. First of all, you're going against the current. And if you're going against the current, then that resistor experiences a positive change in potential. If you go against the current, that resistor experiences a positive change in potential. So this is a positive value here, not a negative. And then also being extra careful that I get the proper subscript here. Now, we have three separate branches here. There are three separate currents. I have I1. I1 starts here, goes around, and I1 ceases right there. I1 does not travel past that point. I2 starts here, and I2 stops right there. I2 does not travel past that point. And then I have I3. So as you're writing the loop equation and the junction equation, you have to be very careful that you get the correct current labeled, because it'll help you when you actually start to solve the equations. Okay, so let's look at the right loop. Oop, what happened there? Pause here while I figure it out. Sorry for that. Let's look at the right loop now. You know, I'm going to pick... I'm going to start at the top here on the right loop, and I'm going to go down. Let me erase some of this. So I'm going to start here. I'm going to go through the circuit in this direction. I'm going to follow it through. So first off, I'm going with the current. So I have minus I2R2. Notice it's negative. Notice I have a 2 subscript because I'm in that I2 branch. I have plus V2 because I'm going like this on the battery. Now I'm going to come over here. I'm going to have a negative V3 because I'm going from high to low potential. And then I have a plus I3R3. And then that's going to equal 0 because that's the last element. Now I can do the big loop as well. For the big loop, I'll come here and I'll go in this direction. So first I have V1 minus I1R1 minus V3 coming along here. Electrons lose energy, plus I3R3. I think that was the last one. Yeah, so, and that's all equal to 0. So now I have 3 equations. You know, you could solve these 3 equations and find out what are I1, I2, and I3. But it's easier to use the junction rule. It's just easier to solve them. The junction rule, you just pick any one junction. So I'll take this junction up here. And you say IN equals I out. So notice here I have I1 going out. I have I2 going out. And I have I3 going out. So what that means is there is no IN in this case, the way that I have it drawn. So IN equals I out. That means 0 equals I1 plus I2 plus I3. Obviously, this doesn't make any physical sense, right? Because I have no current, unless there's no current, unless I1, I2, and I3 are all 0, which they're likely not. So what that means is that one of these currents is going to turn out to be negative, one or more of them. So that doesn't mean anything exactly. These directions were just chosen randomly because we really had no prior knowledge of what the direction of current should be. So we shouldn't be surprised that we chose one or more of them incorrectly. So when we solve for the current, as I'll show you in just a bit, we will find that some of the currents are negative. And if that's the case, when you report the answer, as I'll show you in an example, you just change the direction. So whatever you chose, you take the opposite direction. All right, so that's sort of the gist of solving these multi-loop circuits. There's some nice little rules here with the loop rule and the junction rule, and I'll show you some tricks to that. But first, let's do an example. We'll pick up that next time.